What if the deadliest fighter plane in the Pacific was obsolete the moment it rolled off the assembly line, its fate sealed not by enemy bullets, but by the very blueprints that brought it to life? In the early months of the Pacific War, the Mitsubishi A6M Zero seemed less like a machine and more like a myth made real, a fighter so nimble, so quick to climb, so deadly in a turning fight that Allied pilots whispered its name with a mixture of fear and grudging respect, and for good reason, because nothing in the American or British arsenal in late 1941 could match it in a dogfight. And that reputation was not exaggeration, it was earned in blood over the skies of China, the Philippines, Malaya, and the vast blue expanse of the Pacific, where the Zero shredded Allied formations and seemed to confirm every fear that Japan had built an unbeatable weapon, yet buried inside the very design that made the Zero a legend was a fatal flaw, a kind of engineering original sin that would, within just a few years, turn this celebrated predator into a flying coffin. And to understand how a machine so feared could collapse so completely, we have to go back to the design table in 1937 to a brilliant but constrained engineer named Jiro Horikoshi, and to a set of demands from the Imperial Japanese Navy that would shape not just one airplane, but the entire arc of Japan's air war. Because in 1937, the Navy issued a specification that read almost like a wish list for an impossible machine. They wanted a fighter that could outclimb and outturn anything in the sky, that could fly further than any single-engine fighter in the world, over 1,000 nautical miles on internal fuel alone, that could carry two 20-millimeter cannons in addition to machine guns, and that could still take off from the short decks of aircraft carriers. And Horikoshi, working for Mitsubishi, understood immediately that these requirements were almost contradictory because range demands fuel, fuel demands weight, weight kills maneuverability and climb rate, and the only way to thread that needle, the only way to make an airplane that could do everything the Navy wanted, was to obsess over weight reduction in a way that no other nation's engineers were willing to attempt. And so Horikoshi and his team began stripping the aircraft down to its absolute minimum using a new aluminum alloy called Extra Super Duralumin, sometimes referred to by its designation ESD, a material lighter and stronger than anything used in contemporary American or European fighters, but also more brittle and more prone to stress fatigue and corrosion. And this alloy became the skeleton of the Zero's entire philosophy, because everywhere else in the airframe, Horikoshi kept cutting. The fuselage skin was thinned to the edge of structural safety, structural members were lightened and lightened again, and, most fatefully of all, the cockpit and fuel tanks were left without armor plating and without self-sealing capability, because adding protective steel or rubber lining to the fuel tanks would have added hundreds of pounds, weight the Zero simply could not afford if it was going to meet its climb and range targets. And so the finished aircraft that emerged in 1939, designated the Mitsubishi A6M, often called Ryzen or simply Zero, after the Japanese Imperial Year 2600, was a masterpiece of trade-offs, an airplane that achieved astonishing performance specifically because it sacrificed almost everything that might have made it durable. And when American and Allied pilots first encountered it, they discovered an opponent that could turn inside almost any maneuver they attempted, that could climb away from danger faster than their own aircraft, and that seemed to dance through the sky with an agility that bordered on the impossible. And pilots like Saburo Sakai, one of Japan's most celebrated aces, became symbols of this seemingly invincible weapon, racking up victory after victory in the skies over China and later the Pacific. And the psychological effect was enormous, because for the first 8 or 9 months of the Pacific War, American and British pilots were told, almost as official doctrine, Never engage a Zero in a turning dogfight because you cannot win. And that fear was not irrational. It was based on hard combat experience and devastating losses. But here's the part of the story that almost nobody understood at the time. Not the American pilots who feared the Zero, not even most of the Japanese commanders who celebrated it. The same design choices that made the Zero a terror in 1941 and 1942 were quietly guaranteeing its destruction in 1943, 1944, and 1945 because Horikoshi's team had built an airplane with almost no margin left for growth, no reserve of structural strength to absorb a heavier engine, no spare capacity to add armor without crippling performance, no room in the design philosophy itself to evolve the way enemy aircraft would inevitably evolve. And this is the central tragedy of the Zero's story. Not that it was a bad airplane, but that it was, in a sense, a finished airplane the day it was born. An aircraft optimized so completely for a specific moment in aviation history that it had nowhere left to go. And meanwhile, half a world away, American engineers were taking the opposite approach entirely, building aircraft like the Grumman F6F Hellcat and the Vought F4U Corsair with a philosophy that almost seems crude by comparison: heavier airframes, more powerful engines, armor platching around the pilote chef Sally Fuelkens Chaco absorb heats and keep flying, and, crucially, structural designs with generous margins that allowed for future upgrades, heavier armament, more powerful engines, additional equipment, all with it requiring a fundamental redesign. And this philosophical divide, agility purchased through fragility versus durability purchased through brute strength, would come to define the entire arc of the air war in the Pacific, and the United States discovered the Zero's secrets almost by accident in a story that has become one of the most remarkable intelligence finds of the entire war, because on June 4th, 1942, during the Battle of the Aleutian Islands, a Japanese pilot named Tadayoshi Koga was flying a brand new Zero in a raid on Dutch Harbor in Alaska, and his aircraft was damaged by ground fire, and rather than risk capture, Koga attempted to make an emergency landing on what he believed was solid flat ground on Akutan Island, but the area was actually a boggy marsh, and when his landing gear dug into the soft earth, the Zero flipped violently onto its back, snapping Koga's neck and killing him instantly. But remarkably, the aircraft itself remained largely intact, and for over a month it sat undiscovered in that remote Alaskan marsh until an American patrol aircraft spotted it from the air. And when American forces recovered the wreck, they realized almost immediately what they had stumbled upon: a nearly complete repairable example of Japan's most feared fighter, and the aircraft was shipped to San Diego, where engineers and test pilots painstakingly restored it to flying condition, and what followed was one of the most consequential test flight programs of the entire war, because American test pilots, flying what became known as the Akutan Zero, methodically explored every characteristic of the aircraft: its climb rate, its turning radius, its stall behavior, its diving limitations, and what they found confirmed both the Zero's extraordinary strengths and, more importantly, its precise weaknesses. They discovered that the Zero's ailerons became extremely heavy and unresponsive at high speeds, meaning that above roughly 200 miles per hour, the Zero's vaunted maneuverability began to evaporate. They discovered that the aircraft could not dive particularly fast without risking structural damage to its lightweight airframe, and they confirmed what combat reports had already suggested: that a single solid burst of gunfire into the unprotected fuel tanks or the unarmored cockpit could turn the Zero into a fireball in seconds. And this intelligence was rushed to combat squadrons across the Pacific, and it transformed American tactics almost overnight. Pilots were taught a new doctrine: never turn with a Zero at low speed. Instead, use superior diving speed and energy to make slashing attacks, hit and extend, used the Zero's own fragility against it by forcing fights into the high-speed regime where its agility advantage disappeared and where a single well-placed burst could be lethal, and this tactical revolution found its purest expression in a maneuver developed by a Navy aviator and tactician named John Thach, who, even before the Akutan Zero was recovered, had begun developing what became known as the Thach weave, a defensive formation in which two American fighters flew in a crossing pattern so that, when an enemy fighter latched onto the tail of one aircraft, the other pilot would cross behind to bring his guns to bear on the attacker, effectively neutralizing the Zero's turning advantage through teamwork and discipline rather than raw aircraft performance. And Thach first proved the tactic's effectiveness in real combat during the Battle of Midway in June 1942, and as American aircraft like the Hellcat entered service in 1943, an airplane specifically designed using lessons learned from the captured Zero, with a powerful engine that could outclimb and outrun the Japanese fighter at higher speeds, with armor that could absorb hits the Zero's airframe never could. The balance of power in the air began to shift decisively, and here is where the deeper engineering tragedy of the Zero becomes truly visible, because as American aircraft grew more powerful and more heavily armored throughout the war, Japanese engineers desperately needed to respond. They needed a Zero with a more powerful engine, with armor protection, with self-sealing tanks, with heavier armament. But the airframe that Horikoshi had designed in 1937 simply could not absorb these changes. The structure had been optimized so tightly around its original specifications that there was no reserve strength to handle a significantly heavier engine without extensive and time-consuming redesign, and Japan's wartime aircraft industry, increasingly strained by shortages of skilled labor, by the loss of experienced engineers and workers to military service, by American submarine attacks crippling the shipment of raw materials, and by intensifying bombing of Japanese industrial centers, simply did not have the capacity to undertake a fundamental redesign, even when later models did add modest improvements. The A6M5, introduced in 1943, added some armor and a marginally more powerful engine, but these were incremental patches applied to a fundamentally maxed out design rather than the transformative leap that was actually needed. And the irony is brutal. The very obsession with lightness and efficiency that had made the Zero a revolutionary weapon in 1940 had also locked it into a developmental dead end, while American industry, with its deeper reserves of raw materials, manufacturing capacity, and skilled engineering labor, could afford to build aircraft with generous structural margins from the start, margins that paid enormous dividends as the war progressed and aircraft needed to grow heavier, faster, and more heavily armed. And there's a quieter, more human dimension to this story too, because the pilots who had to fly the aging Zero into combat against increasingly capable American aircraft were not abstractions. They were young men, many of them barely out of their teens, flying into battles where their aircraft's fundamental vulnerabilities were now well understood by their enemies. And as Japan's experienced pilot corps was ground down through years of attrition, through the catastrophic losses at the Battle of the Philippine Sea in June 1944, not merely because Japan had run out of skilled pilots, though that was certainly true, but because the machine itself had become a liability, an airplane that simply could not be made competitive against the F-6F Hellcat, the F-4U Corsair, or the formidable P-51 Mustang, without a redesign that Japan's wartime industry no longer had the capacity, the materials, or the time to complete. And In one of the most haunting final chapters of the Zero story, the very lightness and simplicity that had once made it a masterpiece of efficient design made it, in the war's final desperate months, disturbingly well suited for an entirely different and horrifying purpose, because the Zero's light airframe and the relative ease with which it could be stripped down and loaded with explosives made it one of the primary aircraft used in Japan's kamikaze attacks beginning in October 1944, an airplane originally engineered to dominate the skies through speed and agility was, in its final act, transformed into a one-way weapon flown by young men who had no expectation of returning. And there is a profound and sobering irony in that transformation, because the same design philosophy that prized minimal weight and maximum range, qualities that once made the Zero an offensive marvel, also made it tragically efficient as a delivery vehicle for explosives in suicide attacks. And so, the aircraft that began the war as the most celebrated symbol of Japanese air power ended it as a symbol of desperation. And when we step back and look at the entire arc of this story, from Horikoshi's drafting table in 1937 to the burning wrecks scattered across the decks of American ships in 1945, what emerges is not simply a story about one airplane, but a profound lesson about the hidden costs of optimization, about how an engineering decision made in a moment of triumph can become a trap. Years later, when circumstances change and the enemy adapts, the Zero was not a poorly designed aircraft. In many ways, it was a triumph of engineering ingenuity, achieving performance specifications that should have been almost contradictory through sheer obsessive attention to weight, but it was an AIR craft designed for a single moment in time, a moment when no other nation had a fighter that could match its agility and range, and the moment that single advantage was understood, dissected, and countered, first through the desperate intelligence work surrounding a wrecked fighter found upside down in an Alaskan bog, and then through the deliberate American strategy of building aircraft with the structural reserves to grow and adapt. The Zero's fate was effectively sealed. It could win the opening battles of the Pacific War brilliantly, but it could not win the war itself, because it had no answer to an enemy that learned its secrets and then built machines specifically designed to outgrow it. And perhaps that is the most enduring lesson buried within this story, that in war, as in engineering, the deadliest weapon is not always the one that wins on the day it is unveiled, but the one with room left to become something more. And the Mitsubishi Zero, for all its early glory, for all the legends built around pilots like Saburo Sakai, and the terror it once inspired in Allied airmen across the Pacific, was a weapon built at its absolute limit from the very first day of its existence, a fighter that had already, in the truest engineering sense, reached the end of its own evolution before America had even discovered the precise way to defeat it. And when American test pilots climbed out of that restored Akutan wreck in the autumn of 1942, what they had truly uncovered was not just the tactical weaknesses of a single airplane, but the strategic destiny of an entire air war, a future in which Japan's most brilliant fighter design would be hunted down, not by matching its genius, but by understanding with cold and patient precision exactly where that genius had quietly run out of room to grow.